All right, guys, I'm gonna try to start catching up to you. So with any factoring, you pretty much always start off by seeing if there's any GCF. So a couple of problems on this paper had that kind of happening. Sometimes it might be the only thing you could do, and sometimes it uncovers something you could do after you take it out. This first dude is a very classic factoring problem, right? X squared is x times x, and then it just becomes what numbers make this work. So I need two numbers that multiply by negative 36, add to be negative 5. If I remember correctly, I think all of you got it. Yep. There you go. Now, what's funny to me is students will go further and they'll say x equals 9, x equals negative 4, but there's some dumb jokes about, do you think everything in the universe is 0? That's kind of bleak. So it's not an equation, so you can't get number answers. You can just simplify, you can just break it back up. So on 1B, students will sometimes clue in on that third power. But is everything currently able to be cut in thirds? Hell, you got that one little y dude, can't do anything. 56 out of 7, I don't know, can't do it. But again, what saves your ass is GCF. So what number can come out of both of these? 7. And then I can also take a y out. So here I'm left with a cubed. And then here, 56 divided by 7 is 8. And the y that was there, I took it out. And what have we just uncovered? Try to do that. I'm so tired, I'm sorry. I'm always tired. It just sucks. What kind of thing is 8 cubed plus 8? Oh, okay, I'm sorry. The name of it doesn't matter as much as if you're able to do it. You're right. So it's a sum of cubes, because I can cut everything in thirds. The funny thing is, the minute I started to say something to a few of you guys, you went, oh, is it the little dude, big dude? Okay. And that's kind of like what I do teach it that way, is if you kind of just start the problem, I'm hoping at some point you go, little dude, big dude, oh yeah, little dude, and then you put it down and you start, and then you go, what goes into these things? And I'm hoping that you walk yourself down that path. So little dude, big dude. A cubed, of course, is what? A times A. 8 is 2 times 2 times 2. So what goes in the little tiny dude? Yeah, 1A plus, same sign, yes, 1, 2. So it's a little tiny dude. You can only take one of each. So what has to go in the big dude? Yeah, the other two a's. So I get a cubed. And at the end, I've got to put the other two 2's. So I do get 8. And do you guys remember the S-O-A-P? Do you remember that? SOAP. Same sign, opposite sign, always positive, yes? And then what goes in the middle? What always makes the middle term? Yeah, 2 times A. Cool. Kapow! So the big dude is never factorable unless you left a GCF in there or something. Right? You never factor the big dude using, not just using real numbers, but using non-crazy ass numbers. It would be complex and gross. We don't do it. Okay. Real quick, if this was equal to 0, what's one easy answer? If this was equal to 0, don't forget about the 7y, I'm sorry. If that was 0, negative 2 is an answer, yes? And then this one would give me 2 complex answers, and that makes sense because 2 plus 1 is 3, and that's the third power. It's got to have 3 answers. But it wasn't equal to 0, so this is where you stop. Go! Here, Kim. You don't have to sit at the Thanksgiving table if you don't want to. You're fine.
Okay, you're good. I love it. So then, how do I do part C then, when the first number is not a 1? And can I take a 6 out? Can I take anything out? No. So I gotta take that into account. How do I do that? How do I take that into account? Yes. Take him into account. And then it's the same exact steps we did over here. And very, very funnily, isn't the first number here a 1? And if I do 1 times negative 36, don't I get negative 36? So we actually do this all the damn time. It just doesn't change anything unless the first number is not a 1. So 6 times negative 5 is negative 30. I do the same things we did before. 2 numbers that multiply by negative 30 add to be negative 7. 3 and 10. Which one's got to be negative, so it comes out to be negative 7? And now I rewrite this so the middle term gets broken up using these numbers. And I always put the negative 1 first if I have a choice. Because if that's a negative sign, very often we make a mistake with the negatives. Okay, so look at what I've done. Look what I've done for you. I took that problem and made it worse. Thanks, Jeff. Why is this better though, actually? What can I do now with this? Anybody? Anybody? What can I do? Yeah, now I've got grouping I can do, right? So the minute I've got at least 4 terms, I could try grouping. What comes out of these two? (2b). So I'm left with 3b minus 5. And then what comes out of these two? Nothing, right? But what always comes out no matter what? What can you always factor out of a number? How can you always factor? Now, what's 17? Can you factor 17? Can you factor 17?
Yeah.
Yes. What? Factor it for me. 17 times 1. Okay, yeah. So what can come out of here? 1. Why do I do that weird shit? Because now it looks more like what I'm used to. Are these the same? Why is that important? Because I couldn't do the next step unless these are the same. What's the next step based on? What's the next step now? What can I do? Each of those terms has the same thing. They both have a 3b minus 5. So the same way we were able to take a 2 and a b out of 6b squared minus 7b, we can now take a 3b minus 5 out of both of those. And then what would be left? Don't do that to me. 2b plus 1. Kick ass. And of course, whenever you factor something, you can just multiply back out to check yourself. This, of course, is please excuse my dear Aunt Sally, dumbass son, whatever you like better. And the biggest mistake is students will make this 20, and that's not fair. Because what is the only thing I'm dividing by in this problem? Let me do this while I think about it. What's the only number being divided by? What's the only number that this is asking me to divide by?
What?
10. So look at it again. What's the only number that this problem wants me to divide? Until it's like, say it one more time. I'm sure it'll make sense if you say exactly the same thing one more time. So that's the answer. 10 is the only number that I am dividing by anywhere. So if you do 10 times 2, that's not fair. all of a sudden I'm saying I'm dividing by 20 now. That's not true. It doesn't say divide by 20, it says divide by 10 and then multiply by 2. So the biggest mistake students make is they do 10 times 2. And I don't blame you because your brain goes, oh, I know that shit. It's 20, write that down. And you're like, no, brain. Where do I start though? What's the first thing I do? Yeah. What's the last thing I'm gonna do? Yes, so this guy is just gonna come for the ride the whole way. 3 minus 5 is? Negative 2. Negative 2 squared is? 4. And now this whole thing is nothing but division and multiplication, so I do it as it comes. Right? 5 times 4 is? 5 times 4 is 20. Divided by 10 is 2. Times 2 is 4. So then I do 6 minus 4. 2. Are you guys okay? All right. Part B is literally just the same problem as this. The step we normally don't do when it's just numbers is we normally don't actually write this step out. But if you wrote this step out, you can see why it reduces, because I just kill the common factors. So I do exactly the same thing here because x's are just numbers. So they have to act the same way these numbers do. How do you factor the top?
X plus.
Yeah.
X minus.
X minus, it sounds better.
X minus.
Yeah, little dude gets 1 of each. Big dude gets 2 of each. And then the middle sign is opposite, so it does its job. And then 3 times x. Now, real quick, does anybody remember what the middle dude's job was? The 3x in the middle. Somehow I related it to a movie called Pitch. What's that? There's a guy out here killing people. They're not the list dying. They're like, oh shit, here he is. Oh shit, sorry. The middle guy's job is to cancel the terms we don't want, right? So of course it's got to be the opposite side, so it can actually do that job. It has to be the opposite side, so it can cancel the stuff I don't want. Now the bottom, what do I do first on the bottom? Take a 2 out. I'm gonna write it right here just so I have. And then how do I factor this? What numbers multiply by negative 12 had to be 1?
X minus 3.
Yeah, 4 and 3, and the 4 has to be positive, and then of course you can reduce this. What cancels? Yeah. So you just get this over twice this, and that's it. Cool. So that's just like the first kind of level thing that you could do with factoring. Part C is just straight up like terms, right? Distribute the negative. And then just put your like terms together. So we got I plus 9. Is that what you guys got? I really hope so. Okay. This one, and this one, and this one to some degree, you have to know what I squared is. But the first level of this is just a stupid little variable, right? We know it's not really a variable, but we pretend like it is. So we get 3i minus 18 plus 2i squared minus 12i. And so it feels as if it was an x, but what's the difference? What do I know there that I normally don't know? Yeah, I know I squared is negative 1. And then I just put my like terms together. Okay. How you guys doing? And just to remind you guys, this is actually exactly the first few problems. Not exactly, I did change some of this to make it a little different, but from the first practice test. This is from our first practice test. Of course, it was about 3.7 billion years ago. What do I do with this one? I think I got around to a few people to remind you. Yeah, if I multiply by what was called the conjugate, and the names of things is nowhere near as important as how to do things. So
So on the bottom we get we get 9, and then we get plus 6i minus 6i, which is a huge reason why we do what we do. There's only a few places where I could still be alive. In the middle term, well, the middle terms just kill each other. And in the last term, but what's the last term do? I squared is? -1. Yeah, so the bottom that won't have an I anymore. Poor little dude. And then up top I just distribute. So everywhere I see an I squared, I can replace it with -1. So this will be 9 plus 4. And just to remind you guys, how do I know when I'm done? Well, a complex number has to be in the form a plus bi. And sure enough, I get -8/13 plus 12/13 I. That's a plus bi. Let's see, I've talked to a few of you guys about part F, and I drew this little picture for you. This is the picture I wish my teachers would have shown me. So I to the 0th, I to the 1st, I to the 2nd, I to the 3rd, I to the 4th. So now that we've gone through trig, this is going to make more sense. I to the 33rd has a bunch of freaking rotations in it that we don't need. So when we divide by 4, we are just literally saying, hey man, don't spin around like that. So what's 33 divided by 4? I don't care. What's the remainder? 1. The remainder is 1. So you're going to spin so many times, and then you're going to go one step more. So where do I end up if I do that? I'm one step in. So I spin, whee, and then I take one more step. Time. Do it again.
I do a circle, like rotate it to 1 to the -2.
If it helps, that's all that matters. It's not really part of what I'm asking you, so it's just a little tool to help yourself out. Yeah.
Yeah.
I think another way to think about it too is maybe like I to the 4th and that the 8th power times another I.
Oh, yeah. So if you want to see more literally what we're doing, it's this, and then this is I to the 4th to the 8th. This is 8 rotations. Go 4 steps 8 times. Well, that's 8 rotations. And that's why all we're left with is I. So that's a more computational way. And the really funny thing is, I don't know if you guys know this, but I'm a math teacher, and when I was taking a physics class, one of my first physics classes, the teacher said, "Are you comfortable with math?" And I'm like, because I was answering some of the questions without using math because I thought it was more interesting to look at it a different way. So this is a beautiful way to do it. There's not a damn thing wrong with it. But I kind of lean in the direction of visual when I can. But if you don't like that as much as I do, you can certainly do it this way instead. Yeah. Okay. Oh my God. Sorry. What in the world? So can somebody remind me for radicals? What does square roots have? Do they have an issue with inputs? Do they have an issue with certain inputs? Yeah, they can't handle negative numbers because then they'll be complex. And whenever I give you a function problem, if I don't say, we're assuming we're only using real numbers. What about cube roots and all the odd roots? What's the cube roots of -8? Is there a number? Yeah, because -2 times -2 is 4 times -2 is -8. So odd numbers of things could keep the negative signs, but an even number of things can't keep the negative sign. That's why even roots can't handle negatives, but odd roots can. Now, all of that is to say, the domain are the values of x that would actually work, that won't make it undefined or complex. But what did we just say about cube roots? What kind of numbers can they handle? Any. So what do you think the domain of f is?
Negative infinity to infinity. There's any odd root is so cool with any number you put into it.
Let me say any real number for right now. It can handle complex, but we don't have to think about that. So the domain of F would be all real numbers. You could also write that as all real numbers, or you can write all real numbers. I don't care. All those say the same thing to me. What about G? G is pretty straightforward, yes? What can G not handle? Zero. So you could just write this. I don't need all the extra shit. Or if you like to, you could write negative. Oh, can you, Jeff? Negative infinity to 0. Union was 0 to infinity. But do you understand why I don't like this necessarily? Because it's just quicker to say the same thing this way. But if you write like that, you're completely fine. Hell, if you do it for another teacher, they might like you better. Personally, I don't give a shit. They both say the same thing. Okay. Now, part B is the one that everybody always misreads. I did not say what's f of 0. I said, when does f of x equal 0? So you literally have to take f of x and set it equal to 0, which sounds very exciting. How do I solve that resultant equation? Yeah, I want to isolate where my x is. Whoa, I'm lagging in real life. That's weird. I want to isolate where my x is. So I want to get rid of this. And then I can free my x up. How do I free my x up? How do I kill this cube root? Yeah, a third power kills that. And what is negative 2 cubed? Negative 8. Add 3. And then divide by 2. Oh shit. Let me show you what's going on.
I just want to say a little something too. If it feels like you have to remember a lot, I want you to realize there's more stuff they have to know in 176. So, in terms of amount of stuff you have to remember, you've chosen wisely. They got to remember a little bit more. What do you do with part C? I mean, if I just said what's f of 3, like, why didn't you just say that, Jeff? I know how to do f of 3, just by 3. But what am I trying to shove into f?
G of 3. So if I don't know what G of 3 is, I can't do what it wants me to. So I got to first figure out, well, what's G of 3? What's G of 3? 1. Now I can plug that in, because now I know that's 1. And did anybody do that? Did you guys plug a 1 in? Cube root of negative 1 is? Negative 1 plus 2 is? What? All right, I am the king of not enough room. What does this symbol here mean? Inverse, not reciprocal. Those are completely different things. There are very few functions whose inverse is just the reciprocal of that function. So if I look at this, how do I find the inverse?
Set equal to 0 and then
No. I bring y back.
solve
No. Sorry, Trent. You're doing fine.
solve for x and then you have
No.
Move everything to one side.
No. How do you find the inverse graphically? I give you a graph.
do everything opposite.
Be more specific.
Take away.
Oh, input for output.
Yeah, just switch the, you can do it, switch the, what's another quick way to say input output? X's and Y's. So what do I do here?
No. What did we just say? What did we just say?
I was gonna say flip, solve it, and then change.
Switch the x and y. Yeah, I mean, mathematically, you end up in the same place if you switch x and y at the end, right? But I just like to do this because I'm weird.
But the reason I like this is because the first step, what do you do when you're trying to graph the inverse of a given graph? You just take every point, switch the x and y. So I want it to be exactly the same. How do you do a function? Oh, you just switch the x and y. And then so on, right?
So how do I solve for y? How do I solve for y, guys?
Add something
Yes. So you find where your y is, and you get that term by itself first. How do I kill the cube root so I can get at my y? Cube both sides. Please, dear God, don't actually cube this shit. There's no reason for it. And then what's the last two steps here to get y by itself?
add 3.
Yeah, add 3 and then divide by 2. Is that all right? And that would be f inverse. Yeah. So f, oh my gosh. Where did f go? There he is. F subtracted 3. G adds 3. F doubled. G cuts in half. F cube roots. G cubes. Blah, blah, blah. So they each do the opposite of each other in the opposite order. And that's exactly what an inverse should be. And then finally, this weird thing. This is just a long-ass way to say slope. Remember the average rate of change, and some of my colleagues call it a rock. What you do is you take a rock. So the average rate of change really just means slope. That's going to become huge the first few weeks in Calc 1. And all the slope is the difference in the y's divided by the difference in the x's. And y's are just outputs. So what are my inputs?
1 and 6.
Yes. So when I give you an interval like this, that's x goes from 1 to 6. So I know that my x's are 6 minus 1. And to get my outputs, to get y2, I just shove x2 into f. Oh, sorry, in this case, g. So I just really want you guys to remember, y is an output. G of 6 is an output. So how can I rewrite g of 6? Y. In this case, I call it y2 to distinguish it from y1. The second output versus the first output. The second input versus the first input. But I need you to remember, average rate of change just means slope. So how do I find it? I use the slope formula. Difference in the outputs divided by difference of the inputs. What is g of 6?
1.
That's exciting. What is g of 1? 3. And what is 6 minus 1? Shit, you can't see what I'm doing. 5. Now let me show you a really cool way to do this. What sucks about this?
Top is negative and it doesn't.
Well, fraction inside of a fraction, yes. How would I kill that fraction? How would I kill him?
Just write it as 1.
Just poke him? Enough? No. So if I am totally allowed to multiply the top and bottom of any fraction in the universe by 2. So I'm going to double the top and the bottom because when I do that, these kill each other. What's 3 times 2? Holy shit. So that's a nice way to kill an internal fraction that's inside another fraction. Just multiply it by its denominator, top and bottom. Every other number gets bigger, but I can deal with that as long as I kill my fraction. That's better. And then what do I get here? I just get negative 5 over 10, which is?
-1.
Yay. Okay. Oh my God. Sorry. We did a good chunk. Okay, so that is the last problem on this. If you guys want to, I can take like specific questions. We also have the option to have a very early day if you want to. So we can either do specific questions from the practice test, from the last quiz, from whatever, or we could leave early
all of you guys gotta practice final, yes? So if you want to, you can grab questions from the practice final, we can go over those. Homework questions. Yes?
What's the like synthetic division or something? It's like I don't know, it's the second part of synthetic division. I don't know.
Second part of synthetic division. I'm not sure.
But it's like with this instead.
Is that a matrix?
I think he's just asking about synthetic division, just how to do it.
Okay. So guys, help me out. Let me make a problem that will invariably end up looking gross. How would I synthetically divide this thing?
You like the penalty box at plus 4.
Yes. So we decided the variables don't have to be included. That was extra writing. We didn't need them. Yes?
Yes.
So then that would be a -4. But then we also said to ourselves, well, shit, man, I had to change the dumb sign every time. Let me just change the sign right at the beginning. Are you guys at all with me? That's pretty literally, it's not even a drunk history of math. It's pretty literally what we did. And then what goes up here, since we don't care about the variables? 1, 5, -4. Why didn't I have to put any zeros here? Because every power is represented from the highest to the lowest, yes. You guys with me? Okay. And now, how does this process work? Once you see it, it just runs itself. Yeah, bring down to 1, it gets things started.
4
4 times
times 1.
1.
Add
Add,
9.
multiply. Good Lord, Jeff.
Add.
It's impossible for me to make a problem that doesn't go crazy. Yeah, that's 128. Ooh, Trent busting out the deep hits, the deep cuts. Since I divided by a positive number, and every coefficient answer was the same sign, this is an upper bound. Yeah. If you were trying to factor this, which since I put an 11 at the end, doesn't sound like it's would work. Is that okay?
So you just leave it like that, you wouldn't break down like that. Is there anything?
Oh, sure. To write the answers, if this was a cubed and then divided by effectively x, so what is this the coefficient of?
2.
Yeah, x squared. And then it would be plus 9x plus 32 plus totally. And just real quick, if I did 7 into what, Jeff? I don't know, man. 17. That would be 2, 14, 3. We are not in kindergarten or whatever, so we don't put big ass R. What do I put next to the 2?
That's the 3 overs.
Yeah, so this shit is the same as that shit. This shit, same as that shit. This shit right there, same as that shit right there. It's exactly the same reason, exactly the same way to write it. And what this really means is I was 117 off from this being factorable, from this being doable. So yeah, I was a little off. Yes.
If we just do an A, can we do 2A on the practice again?
Sure. Oh, there it is.
Is that one less confusing?
Oh yeah. Do. Yeah, I'm sorry. You guys, if you wanted to, you can turn yourselves around. Because that's what it's all about. So what's wrong with the location of our unknown in this problem?
It's standard of
Yeah, it's really stuck.
Alright, so before we learned about a certain kind of function, we had no way to get that sucker to come down.
Cat's stuck in a tree, we have messed up.
Cat stuck in a tree. So what do we call it? We call it firefighter. and they bring their logs. Yes.
Oh.
And they construct a ladder out of the logs. So the whole idea is that there's only one function that we know of that could possibly make this come down. So real quick, if I had this problem, what would I do first?
Square.
Because that's the one function that we know that can definitely make this die, is if I square. So the one function we know that can make that free, but make that come down out of there, is a log. And we normally write natural log just because there's one less letter. So then this comes down. Now, how do I solve for x? What's kind of like extra that I wish wasn't on that side so I can solve for x easy? What do I wish wasn't over there with the x? That's kind of like game of math. Yeah, natural log of 5. If only that dumb dude wasn't there. But okay, well, how do I make him go away? Divide. All this shit is a number. All this is a number. So I get 2 minus 5x equals a number. So how do I solve for x? You can do it.
Add.
No.
Okay.
Yeah. You could add 5x, but that's a little extra work. And then divide by negative 5. So you get x equals all this business here. I mean, you could clean that up, but it almost doesn't matter. And if I ask you for an approximation, then you throw this in the calculator and then you get your decimal. Yes. This is the exact answer. Any decimal you give me will be wrong, but it will be close if we round it smartly.
Do you want us to leave it like that?
Hell yeah. Now, if this was like a word problem, and you're like, Billy is asking Tommy how far away he lives, and you solve the equation, Tommy's not going to go, natural log 29.6 divided by natural log 5 minus 2 divided by 5 miles away. Halfway through that, the guys won't go. I'm not going to deal with this shit. I'm sorry. So, if I ask for an exact answer, that's what I mean. If I ask for an approximation, throw it in the calculator. Yeah.
The last exam, did you give us like a sheet of like the completed version?
The which one?
You gave us like an answer key.
Oh, yeah. I'm going to give that to you on Tuesday. If I think about it, I might put it in Canvas before that, but I don't like to give it too early because people end up just staring at it instead of trying the problems out. They just stare at the answer key. So.
I don't know where to start. I'll use it to like where it's at.
If you remind me, I can try to throw it up into Canvas by like Sunday or Monday or something. So you have a little bit of time to do it if you want. Yeah. Huh? Yeah, exactly. There you go. You can't complain. I'll put it up there early. Huh?
You just say ESU and ask something.
Yeah. Alright. How are we feeling? Do you think any other things we want to focus on now, or is there anything we need to Not. I don't think I really focused on those too much.
Did I didn't put anything on the practice test, did I? No. I mean, those are important, but not as important as a lot of this other stuff. They don't really show up too often in calculus. To be really honest, they don't really show up too often, period. And when they do show up, we actually work with them differently than we do in class. So, I guess the short answer is no. I won't put that on there. How that makes you feel? Probably good, because piecewise always confuse the students, yes.
What's the unit?
What's what now?
The variable.
Oh, that's kind of like pi. They don't equal the same thing, but are you asking for an approximate value for
No,
it?
it's like if it's in a problem like natural log e raised to like.
Oh, I see. Well, help me out. What's the base understood to be here?
10.
Oh, E. How do I write an understood base 10?
Just log.
Everyone knows it's log. It's log. So that's base E, that's base 10. So what's the natural log of E to the W? Just W, because natural logs and bases to a power kill each other if they're the same base. Because they're inverse functions. Yeah. All right, guys.
Have a good weekend.
See you, Trent. You too. Oh, sure, yeah, we'll do that on Tuesday. I was considering putting on this, but this was already had enough stuff on it. But we'll focus on like completing the square. Completing the square is a important idea by itself. Oh, which quadrant is 3, 5, and 4 in? So then cosine should be negative. And I couldn't tell it not, but then I realized that's sort of like just the way you make your radicals. Or is that negative? Oh, I didn't even pick up on that. I was so focused on this. So that is a negative sign. Oh, so negative times negative, that should be plus. But that shouldn't be negative because sine is positive, because y is positive with the sign. Yes? So I totally just thought this was a negative. I just thought that was part of it. Because I saw this and I looked over here, oh, that's just part of the thing. So I was like, did you need this to be negative? Because it's supposed to be negative. And then that should be plus the negative 2. Yeah, you can't, those aren't like terms, so you can't put those together. Yes. The most you can do is put it all over 1/4 since the bottoms are the same. Whoa. Everybody let them they're sort of like synthetic in that we just put the coefficients of things into them. But then it's not division we're trying to use, a very different thing. So
I think Wyatt is like a class.
oh, Wyatt, yeah. Yeah, matrices are crazy.
They're used in design